Welcome to Section 4 of the Micromachining Lab module, where we discuss the details associated with performing a micromachining experiment. The objectives for this section are to 1. Learn about G-code programming, 2. Learning about the touch-off procedures that are vital for any micromachining application, and 3. The steps you'll need to complete to perform your micromachining cutting experiment. To get started, we'll first look at G-code programming. G-code was developed in the 1950s as a way to communicate precise machine movements in order to create a part. G-code is based off of numerical control that controls everything on the machine, from moving to a precise location, to turning on the spindle and coolant, and even automatically changing tools. While machines vary from place to place, the standardized commands used in G-code remain the same, some of which we'll talk about on the next slide. Next, we will look at a sample of G-code programming. To start off, we see that the M6 command changes our tool to T1, which is the tool in the T1 slot of the machine. G43 and H01 are offsets that we set as the machinist. G54 defines the workpiece coordinate location that we define as 000. The M3 command turns on the spindle in a clockwise direction. G00 represents a rapid movement. Note that rapid movements of the machine tool should only be performed if we are sure that we will not hit the workpiece or any fixtures that are in our machine. And finally, the G01 command is what we use for all experimentations because it allows for a controlled movement of our machine tool at our specified feed rate. Before we start our micromachining experiment, it is important that we touch off our tool to define our origin location. This is done in 2 steps. First, to define our XY plane 0 coordinate, and then define our Z0 coordinate. In XY, we simply position our tool in the location at the beginning of the slot we would want to mill. Then we use the commands that we described on the previous slide to 0 that location. Meanwhile, for the Z-axis touch off, this is different based on each tool that we use. And to accomplish this, we'll discuss it in a future slide. To perform the micromachining experiments in this module, you will download the associated text files from the online portal. In each of these text files, there are blank variables that you have to fill in with the appropriate process parameters for feed rate. Please use the Section 2 cutting speed calculator if you need assistance with these calculations. All the required information that you need to calculate these variables are seen on the next slide. However, it is important to note that the cutting speed calculator outputs variables in metric units, and we are using an English machine. After completing the variable calculations, please see the micromachining instructional video at the time specified on the slide to see the cutting experiment in process. If you are interested in more details about the specific buttons and functions that we use to touch off the tool and set up our micromachining experiment, please see Appendix A through C in the following slides to learn these details.
As you can see, if I start moving the handle jog wheel in a clockwise direction, the table starts moving towards your left. And if I do the opposite, it goes the opposite way, straight forward. Now, that was in the X direction now. If we do the Y direction, if you move it clockwise, the table moves towards you, and if you do counterclockwise, the table moves away from you. Same thing with the Z. Now we're going to do the Z direction. The Z direction, if you move it in a positive direction, the spindle itself goes up. And if you move it in a negative direction, the spindle itself goes down. So try to visualize this while you're going to the lab, because once you start doing some touch offs or whatnot, you're going to have to realize what it is that the spindle is going to do before you actually make the action. Because if you go into the workpiece, for example, you're going to break the tool before any of the cuts actually take place. Now that we familiarize ourselves with how to control the machine, we're going to start touching off the axes. For the purposes of this project, the way that we produced our code, we wanted to find our axis origins on the bottom left edge. Okay? So with that being said, we're going to begin by moving our spindle closer to that edge. And the way we're going to do that, okay, so we're going to move in the appropriate axis. So I'm going to start off by moving the spindle closer to the workpiece, like so. Now, before touching off, you're going to want to make sure that you bring the spindle to about 1 millimeter from touching the actual workpiece. The reason you want to do that is because that'll give you more of an idea of where the actual tool is in relation to the workpiece. But again, you don't want to touch the workpiece at this time. Okay. So what we're going to do right now is just bring the X and Y axis to where it is that we need to do it. Okay. Okay. So now that we got close to where it is that we want the spindle to be in the X and the Y axis, the next thing that we have to do is set those axes, or we need to specify to the machine that that's the axis origins that we want to have. So the way we do that is by pressing the offset button. Once we do that offset button, once we press that offset button, you're taken to this work zero offset window. Now, in terms of the G code, the most important line here is G54. G54 specifies to the machine your local axis origins in relation to your global axis origins. So like I said, we set our X axis and our Y axis. So what we're going to do now, we're going to press the part zero set button here. So as you can, I'm not sure if you were able to notice, but the number itself changed in relation to what it was now. So now we set our X-axis origin, and now we're going to set our Y-axis origin by pressing the same button, part zero set. So continuing with the process, we're now going to determine the tool length offset. The reason we want to do that is because we want to make sure that the machine knows where the tool tip is relative to the workpiece. Okay, so for the purposes of this demonstration, I changed the first tool to the second tool because it's easier to see the chips that you need to form when you touch off the tool. So continuing, once we press the clockwise button, as you can see, the spindle starts spinning. As I mentioned before, the spindle starts spinning at about 700 RPM. Again, this is just a safety feature so that we don't cut ourselves or anything of that sort. So now, in order for me to have better control of the spindle, I'm going to change the step size of the Handile Jog wheel to 0.001. So we go Handile Jog, press the 0.001 button. Now continue by pressing the Z. We're going to start lowering the spindle towards the workpiece. Be very careful when you start doing this because again, you don't want to break the tool by inserting it all the way into the workpiece. And what you're looking for now is just for the first sign of a chip to start forming. Okay? So let's begin the process. see, we started making we did the first chip. We made the first chip. That to us indicates that the tool started just grazed the workpiece, and from there, that's an indicator for us to set the tool length offset. The way that we're going to do that is by pressing the offset button. So if you remember, once we press the offset button, it took us to this work zero offset window. If we press it one more time, it'll highlight the tool offset table. One thing to keep a note in this particular window is that the leftmost column corresponds to each of the different tool slots. So now you got to make sure that you're highlighted towards the appropriate tool slot. So in this particular case, we're using the second tool, and that's why we highlighted the second row corresponding to the second tool slot. We then arrow to the length offset geometry. So now what we're going to do is press the tool offset measure button, and that's going to indicate this number here indicates to the machine that is when it first starts grazing the workpiece.